Yeah, so yeah, back to the third case here. Yeah, we can calculate V naught directly, yeah, because let me label this. Yeah, the black part is KLP, and then the red part is KLPP. Yeah, so we can calculate V naught by simply using the formula for KLP, which is S over T, which makes it 40 divided by 8 results in 5 meter per second. Yeah, for the acceleration, however, we cannot really calculate the acceleration, yeah, because if you remember, A is V minus V naught over T. Yeah, here we don't have the information about the time. Yeah, if we had the information, then we can calculate it. Yeah, 4 minus 5 over T. Yeah, just plug in any T when you get the information. Yeah, but since in this question, yeah, we don't have T. Yeah, so you can stop right here. Yeah, 4 minus 5 over T, or you can write it down as negative 1 over T meter per square second. Yeah, this is fine. Yeah, of course, later in your exam, I will give you enough information to actually calculate the final result. Okay, I think that's all for these exercises. Yeah, any questions before we move to the second part? Yeah, the freefall motion. Not yet. Okay, good. Yeah, if you have any questions later after this class, yeah, just use the Hangouts group chat. Okay. Okay, the second part then we will talk about freefall motion or GJB, gerak jatuh bebas. Yeah, freefall motion happens when an object experiences Earth gravity from some height. Yeah, so freefall motion is actually just KLBB on the y-axis. Yeah, we will assume that there is no movement on the x-axis. Yeah, and we also assume that no other forces happens to the object. Yeah, for example, like wind, drag, or something. So we purely observe the motion of KLPB on the y-axis with no other external forces. Yeah, for the Earth gravity, we call it G. Yeah, it is usually 0 in the x-axis and negative 9.81 on the y-axis. Yeah, let's assume that y-axis points upwards for the positive value. So G points downward, yeah, towards the center of the Earth. Yeah, and the unit is meter per second square. Yeah, although this value is not really uniform across the globe. Yeah, but we can assume safely that the gravity is negative 9.8 roughly. Okay, so in a freefall motion, the mass of the object is ignored. Yeah, so no matter how heavy the object is, all objects will fall in the same acceleration. Yeah, which is g. Yeah, of course, the assumption is only valid when we only observe the gravity force. Yeah, and excluding other external forces such as wind drag. Okay, about the formula, the math is really simple. Yeah, just replace A with G. Yeah, so here V equals to V naught plus G times T, and the displacement or the distance, or sometimes people write it down as H, denoting height. Yeah, S equal to S naught plus V naught T plus a half of gravity times time squared. Yeah, as long as you use the G equals to 0 and negative 9.8. Yeah, the formula will short themselves out, as you remember your high school teacher taught you. Yeah, if you plug in negative 9.8, this plus sign on the v equation will become negative. Yeah, and as well in the s equation, this v naught t will become negative half of g and t squared. Yeah, so it's really simple. You don't really need to memorize uh, a specific formula for freefall motion. Yeah, just use the uniform acceleration or KLPP, but remember to replace A with G. Yeah, so it is very simple. Let's do some another exercise here. Yeah, let's say a monkey drops a coconut or from its tree. Yeah, if the coconut falls onto the ground in 1.5 seconds, how high was the coconut? Yeah, let's use the integer value for g. Yeah, let's use g equals to 0 and negative 10 meter per second squared. Okay, so I will draw this problem. Yeah, let's say that this is the ground. Yeah, and y-axis, oops, sorry, y-axis is always pointing upwards for the positive value. Yeah, let's say this is the coconut falling down. Oh, yeah, falling down. Yeah, it falls for 1.5 second. And let's use g equals to 0 and negative 10 meter per second squared. Yeah, so this question asks how high was the coconut? Yeah, calculate S, or sometimes people write down as H. Yeah, both are the same terminology. Okay, how to actually calculate this? Yeah, you have the acceleration, yeah, which is g over here. You have time, 1.5 second. What else is missing from this equation? V0, V naught, yeah, V0. We don't know the V0 yet. Okay, because if we plug in the equation, yeah, S equals to, and let's ignore S naught for now, V naught T plus half of G times T squared, yeah. How much is V naught? Yeah, as long as in the question, yeah, it does not state that the coconut is thrown below, yeah, then it can be assumed that the object is actually false from standstill position, yeah, which will mean that v naught is 0. Yeah, as long as the question does not state that the monkey throws the coconut down, yeah, usually I will give you the initial velocity or v naught. Yeah, but if it is missing, yeah, this question just says that a monkey drops. Yeah, so when you drop anything, you drop it from still position, right? So it means that the object initially does not move. Yeah, so the v naught is 0. Okay, let's plug in everything we have here. V naught times t, of course, 0. Plus a half of negative 10 with 1.5 squared. Okay, 0 plus negative 5 times 1.5 squared is 2.5. 10.25 here. So I think can you help me to calculate this? 10.5. Oh no. 11.25. Yeah, 11.25 here. 11.25, and if we follow the sign, it will result in, oops, sorry, negative 11.25. Negative 11.25 meter. Yeah, but this is actually the displacement. Yeah, this is actually the displacement. If I consider the direction, yeah, it means that the coconut falls down 11.25 meter downward. Yeah, and notice here the sign is negative, and remember that y positive is upward. Yeah, so everything is correct now. Yeah, if you are asked how high was the coconut, then you can simply just ignore this negative. Yeah, so the coconut was 11.25 meter high from the ground. Okay, any questions? Yeah, so basically freefall motion is KLPP in the y direction. You can just use the KLPP formula. Yeah, just remember, replace A with G. Any questions maybe? Not yet. Okay, good. Yeah, so for the next part, yeah, it is Unity time. I have provided the video for you in your Google Classroom. Yeah, for now, yeah, let's continue asynchronously. Yeah, you can start your Unity now and watch the video. Yeah, if you have any questions, then you can ask me in the Hangouts group chat.